Okay, the first thing I would try here when you look at this is, does u substitution work? Let u equal x to the 6th plus 4, but then the derivative of x to the 6th is 6x to the 5th. That doesn't match this exponent here. So since I see a square root symbol here, next thing I would try would be trigonometric substitution. So here's the little right triangle. It helps you visualize what's going on. Visualize these as the legs of a right triangle, since we're adding the squares. And the square root of x to the 6 plus 4 becomes the hypotenuse of that right triangle. And we want to use either tangent, secant, or sine, I believe it is. So the tangent of theta is x cubed over 2. If we isolate the x cubed and then take the derivative of both sides, something good starts to happen, because we do get this x squared dx. Divide by 3, and there we have a formula for x squared dx, which is this numerator. And then over here, we got to get rid of that square root symbol by using the trigonometric substitution. X to the 6th will equal 4 tangent squared theta. Plug that in right here. Factor out of 4. Replace tangent squared plus 1 with secant squared. The square root of 4 secant squared is 2 secant theta. And now we're ready to do the trigonometric substitution. The x squared dx we have seen is this 2/3 secant squared theta, d theta. And the square root symbol can be replaced with 2 secant theta. This 2/3 over 2 reduces to 1/3, which I'll move out front. Secant squared over secant is secant. And now you have to know how to find the antiderivative of secant theta d theta. You've probably done that already, but there's the formula for the antiderivative. That's one of the formulas for the antiderivative of secant theta. And all that remains is to replace secant theta in terms of x. So if we go back to this right triangle, secant is the reciprocal of cosine. So square root of x squared plus 4 over 2. And the tangent of theta we've already seen is x cubed over 2. So we can put this all over 2. There is your antiderivative right there, plus the constant of integration c. Here's a way to test that or check that out on Desmos. If we let big F of x equal our answer, and then we take the derivative, which is f prime of x, we'll get a graph over here. And then if we let little f of x equal our original integrand, these two graphs are identical, which kind of proves the point. Okay, there you go. Hope that helped. If you have any questions, post a comment.